Let's have a look on how the bone tissue is formed. We call that process ossification, and it occurs into forms. First would be the desmogeneous ossification discussed, also known as the Intra Membranous ossification. This process starts with mesenchyma, where some of the mesenchyma cells will be differentiated to osteogenic cells. So the mesenchyma is vascularized. We have blood vessels here, and mesenchyma cells. And they become osteogenic cells, that differentiate into osteoblasts. And these osteoblasts start to produce the bone matrix, and that's how the bone trabeculae are formed, firstly surrounded by unmineralized osteoid, and later on by mineralized bone matrix, in which the osteocytes will reside. So let this be the mineralized form with different color. Okay. So they are the osteoblasts on the surface of new bone trabecule. And we got the unmineralized matrix layer, known also as the osteoid, and later on this becomes mineralized, fully mineralized matrix by deposition of microscopic crystals or prisms, mostly of hydroxyapatite. And this way how the flat bones of the skull vault are formed. And also the maxilla, the mandible, for example the vomer bone, or part of the clavicle. However, most of the other bones in the human body originate via another mechanism called chondrogenous. Ossification. Before we discuss that, let's get back to the newly produced bone trabecule, because I want to point out to an interesting phenomena which depends on the activity of osteoblasts and osteoclasts. So let us say we have the osteoblasts on the surface, and we have also a region where you can find osteoclasts, these bone resorbing cells with many nuclei. If this would be the shape of the bone trabecule at some time point, with the osteocytes in the center. Okay, and the bone matrix here. Imagine what would happen, for example, this part of the population of osteoblasts will be activated. So their activity would be promoted by some signal pathways or hormones. And at the same time, the activity of these osteoclasts would be also promoted. So you have a region where the bone will be growing, and in the future the border will be shifted in this way. So these will be the new borders of the bone trabecle after some time. But here, due to the activity of the bone resorbing cells, the bone trabecle would become smaller, and so on. So this is the basic explanation of growth and remodeling of bone trabecles, and it's interesting that this phenomena could be observed very soon during the embryogenesis and development of the fetal skeleton. So here we have the osteoblasts and their activation. So the bone grows here. And new bone matrix is produced. And we got the osteoclasts, the bone resorption cell, and the balance between these two processes, the bone synthesis and bone resorption, is responsible for the bone remodeling. The bone remodeling is constant, never-ending, omnipresent process in the bone tissue that starts with the bone formation during ossification and carries on during the whole life. So let's discuss the chondrogenous ossification. The main mechanism involved here is called Endo, chondral ossification, and as the term suggests, it occurs inside the cartilage. So the first layer is made of hyaline cartilage with its isogenous groups. It's regular hyaline cartilage with its homogeneous and glossy bone matrix. We call that reserve or resting zone of hyaline cartilage. The chondrocytes, chondroblasts, then proliferate, and you can see in the microscope that the cells are organized in a prevailing direction. This is called the proliferation zone. Then the cells become larger, increased in volume. We call it the hypertrophy, and at the same time the surrounding matrix is calcified. It's not ossified, it's just calcified. There is a deposition of calcium salts in the matrix. So we got calcification of matrix here. And this is accompanied by the hypertrophy, increase in volume. We call that zone of hypertrophy. This ends with the activity of cells that will resorb the cartilage. Similarly to osteoclasts, these cells are called chondroclasts. And again, they have enzymes that can destroy the cartilage. Chondroclasts, destroying the cartilage. And this line is called the zone of erosion, or line of erosion. So a space is made for bone formation. Bone formation here depends on blood vessels that invade this calcification zone, this ossification region, bringing osteogenic cells on the surface. So invading blood vessels with osteogenic cells, mesenchymal osteogenic cells, which differentiate into osteoblasts that will produce the bone matrix. So we got the bone trabecules here, and another bone trabecule here, with the osteocytes, okay, and osteoblasts on the surface. And as we already know, even osteoclasts could be found here from the very beginning. The newly made space is also filled with the bone marrow, including the many blood vessels here. So we got some mesenchymal cells, reticular cells, and the bone marrow cavity is formed here. So we got osteoblasts, the newly formed bone trabeculae, we got the bone marrow here with mesenchymal cells, and reticular connective tissue, and this zone with newly formed bone trabecula is also called ossification or osteoid zone. This chondrogenous ossification clearly depends on formation of a cartilage model. So from histological point of view, we start with the mesenchyma. However, the mesenchyma undergoes condensation, which is called also blastema, condensed mesenchyma. It's called blastema, and it turns to hyaline cartilage that forms kind of a model of the prospective bone. So we got chondral cells, and they form the hyaline cartilage model of the bone. Next, this cartilage model becomes penetrated by blood vessels growing in, usually in the diaphysis. I took here an example of a long bone. So in the diaphysis region we have invading blood vessels. This is accompanied by first ossification of the diaphysis. It's called collarbone, and it's desmogeneous. Okay, so both patterns are combined here. Of color of the diaphysis. This is desmogeneous. Because it starts from the perichondrium of that cartilage. From the perichondrium. The rest is still cartilage. There is a destruction of cartilage in that zone. Which is called the primary ossification center. Okay. The next step the hyaline cartilage persists in epiphysis. There is an increasing medullary cavity here, resorption of the cartilage, and formation of the groove plate between the epiphysis and diaphysis. So this is here we got the ossified collar of the diaphysis. In diaphysis region. This becomes the groove plate. We already know the zones of it, and the remaining hyaline cartilage in both epiphyses. And the next step there are new blood vessels growing in the epiphysis, forming a secondary ossification center that appear later on. So the region occupied by the cartilage is smaller and smaller. Here we have the groove plate with its zone of chondrogenous ossification, or of endochondral ossification. Here we have the collarbone on the diaphysis, the bone collar. Here we already got the medullary cavity with the bone trabecules among the blood vessels. So, secondary ossification center in the epiphysis, bone trabecula. Here is the compact bone of the diaphysis, and the growth plate, of course, and the cartilage occupies only a small part of the epiphysis and the surface of the epiphysis. And finally, once the process goes to its end, the only place where the cartilage remains is the articular cartilage here and over here. Then the growth plate, the distal growth plate, proximal growth plate, and the rest of the tissues turns to bone. Of course, there is this blood supply of blood vessels. The whole bone formation strongly depends on the vascular supply. And we got the bone tissue here. Here with the spongy bone, here with the thick compact bone, and again in the distal epiphysis with the trabecules of the spongy bone. So the important thing, we got the bone marrow cavity, and the persisting cartilage as the articular cartilage, the growth plate, cartilage, the proximal and the distal, and of course finally these growth plate, cartilage undergo final ossification when the bone growth is stopped.